In this video, we're going to explore hypothesis testing. Now, with hypothesis testing, we're trying to make claims about a population parameter. The ones that we primarily deal with are the mean, the proportion, and the standard deviation. You could do variance as well, but those are the three we primarily focus on. We have two different types of hypothesis that we deal with, and we're going to be writing these every single time, which is the null hypothesis and the alternative hypothesis. And the null hypothesis is always a statement about equity, so equals, greater than or equal to, less than or equal to. The alternative is always the complement, and it's a statement of inequality, not equal, less than, greater than. So whenever we're trying to make our statement, we're going to take our word problem that we have, and we're going to look for where is the claim. That claim will help us set up the correct method for our two hypotheses and where the claim is located, which is very important. So it's going to always use one of these three methods for setting up our hypothesis test. So say in this example, I have exactly 25% of men own a video game system. That exactly tells me I should be using the equals and not equals. So exactly, that's a statement of equity, goes in the null hypothesis. P equals 0.25. My alternative is the exact opposite of that, so that's the not equals 0.25. Since this is an exactly statement here in my claim, that means my claim is about the null hypothesis, and that will be important. Second example here, say that a study found that the average female owned less than 12.4 shoes. Less than is a statement of inequality, so that's in the alternative. The opposite of less than is greater than or equal to. So that equal to has to be in one of the two statements. So that's going to be my null, and my alternative will have the less than. And since this is a statement of less than 12.4 shoes, that is where my claim is. It's in the alternative. Now, as we start to get into testing, we will have error possibilities because we are dealing with samples, not the populations when we're trying to test these things. And we have two different types of error, type 1 and type 2. With a type 1 error, what that means is that I should really have found that my null hypothesis is true, but with the data that I collected in my sample, it told me to reject it. So that I end up stating that the alternative hypothesis is true. With a type 2 error, in all actuality, if I had more information about the population, I would say that the null hypothesis was false. But with the data that I was able to collect, I didn't have enough there to reject it, so I failed to reject my null hypothesis. Now, when we start talking within the hypothesis testing, we often focus on the type 1 error with the level of significance. And that's the maximum amount of probability we're going to take for a type 1 error. And we use alpha as the symbol. And typically we either use 0.1, 0.05, or 0.01. If we ever use type 2 error, we have a beta, but it's very rare that we'll use that right now. Now let's look and see which may be cause more issues in the long run, type 1 or type 2 error. Say that we know that the USDA will not allow more than 20% of chicken in a plant to be contaminated with salmonella. And so say they go into a plant and we want to say what would be the difference between type 1 and type 2 error. So first we set up our null and alternative. Since the maximum amount is 20%, that means less than or equal to 20%. That would be my null. Our alternative would be it's over that 20%, greater than 20%. Now, a type 1 error would say that this statement here about the plant is really true, but the sample we got was over that 20%, and it told us to reject that. So this was really true about the plant, but our sample said, nope, get rid of all that chicken. A type 2 error would say, well, this is not true. Really, the plant is over 20%, but in this case, the sample we found was less than or equal to 20%, so we can't reject the null, and we don't know that it really is over that. So that plant would then be approved to continue on, and they'd be sending out contaminated chicken to all the stores. That is much more dangerous than the idea that we pull the chicken away even though it's really safe. So type 2 in many cases is often more dangerous than a type 1 error, which is why we often do our level of significance based on the type 1. Now as we start to get into hypothesis testing, we're going to be using p-values or probability values, and that's probability of obtaining a sample statistic with a value as extreme or more extreme than determined from the sample. If we are doing alternative testing of a less than, we shade to the left, so less than left, and that's what the shaded region represents, is the alternative. The white is all the null. If we're doing a greater than problem, we shade to the right of the value. And then if we're doing an inequality problem, that's two tails, because it could be either way, with it being not equal. So there's 7 steps within our test. We first create our null and alternative hypothesis, along with which one has the claim. We decide what is going to be our level of significance. We then determine which graph should we be using, and we shade correctly on that graph. We then find our p-value, and we compare our p-value to our level of significance to determine whether or not we reject the null hypothesis. Finally, we write a statement to interpret our decision. Now this final thing is very important because there's 2 different things that could potentially happen. And this is why it's important to know where is my claim. If my claim is in the null hypothesis, I am actually rejecting or failing to reject my claim. So it's either I have enough evidence to reject, or I do not have enough evidence to reject my claim. If it's in the alternative, I'm actually finding, and I reject my null hypothesis, there's enough evidence to support the claim. And if I can't reject the null hypothesis, there's not enough evidence to support. So the wording on how I interpret is different. So pay attention to that as you go through your hypothesis testing problems. Here's an example. Say that a university publicizes that the proportion of its students who graduate in 4 years is 82%. So that means, is 82%, that's an equality problem. So my null hypothesis would be p equals 82% or 0.82. That is where my claim is. My alternative is then that it's not equal to 0.82. If I wanted to create a graph, I'd be using the two-tailed graph since it's an inequality. And then if I wanted to actually interpret when I reject or fail to reject my null hypothesis. Now, since the claim is in the null, I'm going to be either stating that it is enough evidence to reject or not enough evidence to reject. So in this case, if I rejected the null hypothesis, I would conclude there is sufficient evidence to indicate the university's claim is false. And if it could not, I'd say there's insufficient evidence to indicate that the university's claim is false. I can't actually say that that's not true, it's just not enough evidence.